Hello, this is Mr. B. Giriraju, Professor of EC Department, Base Engineering College, Hyderabad. So in the last video, I have completed Unit 2. So today I will start Unit 3. So before going to start Unit 3, so once again I will recall previous units. So actually your Unit 1 is the black schematics of the measuring systems. Actually in that unit I have given explanation for the block diagram of measuring system, performance characteristics of the measuring system. So actually that having two characteristics like as static characteristics and dynamic characteristics. So static characteristics means memory less type of characteristics, and dynamic characteristics means memory type of characteristics. So actually with the help of these characteristics we can study accuracy, precision, errors, types of errors, resolution, like that. So actually here, so we can observe three types of errors: uh, gross errors, systematic errors, and random errors. So here to find random errors, we have taken help of the statistical approaches like as arithmetic mean, deviation from the mean, average deviation, standard deviation, and variance. These are the approaches to find random errors. So next we will discuss about the measuring systems. So to study measuring systems we need help of the galvanometer. So your galvanometer is called the meter movement. That means that having some mechanism. With the help of galvanometer you can measure voltage, current, resistance, capacitance, so like that. Here we are having nearly three types of meters. One is the voltmeter. So voltmeter you can think in DC and AC also. Next ammeter in DC. Next one ohm meter. So together is called the multimeter. So with the help of multimeter you can measure resistance, capacitance, current, voltage, so like that. So with the help of true corresponding RMS meter, RMS voltmeter, you can measure voltages in RMS values. Particularly this meter using for the purpose of find complex waveforms. So this is the overview of the unit 1. So unit 2 is the wave analyzers. So actually your wave analyzers you can classify as two types: frequency selective wave analyzers and other one is the heterodyne wave analyzers. The frequency selective wave analyzers operating voltages 20 Hz to 20 kHz, and heterodyne uh, wave analyzer. Heterodyne means mixing of the signals. So this will be operate on the voltage ranges uh, between 20 kilohertz to 18 megahertz. So with the help of these meters, you can understand wave analyzers functions. Actually, wave analyzers having LC circuit and one detector. With the help of LC circuit, you can tune the fundamental frequency. So next one, distortion analyzers. To find distortions in the complex waves, you have to take help of the resistance. You have to follow some approaches like as resistance method, Wien-Bridge method, and T-Bridge network method. Using these methods, you can calculate and estimate distortion errors, distortion values. So next one, power analyzers. So with the help of power analyzer, you can control powers in the industries. So in the same way, spectrum analyzer. With the help of spectrum analyzer, so you can measure values like as voltage, current, amplitude, frequency in the form of frequency domain. So here you can observe our outputs in the form of amplitudes. So you can classify spectrum analysis as two parts. First one is the based on RF spectrum method, and second is heterodyne type of swept spectrum analysis. So these are the idea about spectrum analysis. So idea about wave analyzers. Next part is the signal generator. So generally with the help of signal generator, you can generate waveforms in the form of sine wave, square wave, triangular wave, like that. So this combination is together is called the function generator. With the help of function generator, you can generate sine wave, square wave, and a triangular wave. So in the same way, you can change position of the such type of waves also with the help of varying amplitude and voltage divisions. So and the time period also. So this is the idea about signal generator. So here you can observe some other types of generators also: arbitrary wave generator, video pattern generator, and swept frequency generator. So with the help of these generators, you can study signal generation. So these are the parts of the unit 2. Now I will start unit 3, oscilloscopes. So here oscilloscope, generally you can call as this is the cathode ray oscilloscope, is probably the most versatile tool for the development of electronic circuits and systems. The CRO allows the amplitude of electrical signal, whether they are voltage, current, or power, to be displayed as a function of time. So actually a CRO will give output signal in the form of x-axis and y-axis direction. So on the x-axis, so you have to consider time, and the y-axis, so this is the vertical, so you can take as frequency, so amplitude, so like that. So actually here the CRO depends on the movement of an electron beam, which is bombarded on a screen coated with a fluorescent material to produce a visible spot. So if the electron beam is deflected on the both conventional axis, that means x-axis and y-axis, a two-dimensional display is produced. This is the picture you can see on screen of the CRT. Here CRT screen is the combination of the fluorescent material. So according to our requirement, with the help of phosphorus, we can arrange that particles in the form of our requirement. Suppose for black and white, so you should arrange alternatively black, white, so like that. So for color system, you have to take primary colors representation like as BG or blue, green, red. So you also you have to arrange in the form of alternate. So one blue, one red, one green, so like that. So these are the arrangement of the screen. So now I will explain block diagram of general purpose of oscilloscope. Actually, in our laboratory, you can observe that is called the general purpose oscilloscope. So majorly this having blocks are first CRT. This is the tube, cathode ray tube, and next vertical amplifier. So with the help of vertical amplifier, you can amplify input signal. Next delay line. So actually here we are having two amplifiers, vertical amplifier and horizontal amplifier. So with the help of vertical amplifier, you can generate vertical signals to CRT for the vertical plates, and with the help of horizontal amplifier, you can amplify sawtooth time output of the time-based generator. So this will through horizontal amplifier, you have to provide signal to uh, Y plates of the X plates of the CRT. So actually there is a gap between vertical amplifier and horizontal amplifier. So we need, in that case, we need some help of the delay line. So actually to run this CRO, we need help of the sawtooth waveform. So that is the reason now you have to take help of the time-based generator. So with the help of time-based generator, so you can generate sawtooth waveform. So to run this, we need help of the trigger pulses. So with the help of trigger pulses circuit, you can generate trigger pulses. So to run overall parts with the help of power supply. So here maximum we will try to apply high voltage, positive high voltage and high voltage and negative high voltage. So these are the parts of the block diagram of general purpose of oscilloscope. So now I am going to explain one by one. Actually, we are having seven blocks. Now I will explain one by one. So this is the basic block diagram of the general purpose of oscilloscope. So this having blocks as vertical amplifier, delay line, trigger circuit, time-based generator, horizontal amplifier. So this is the power supply section. As I have mentioned here, high voltage and low voltage also. High voltage is negative and low voltage positive. So you can observe like this. This is the basic arrangement of the CRO. So here first one CRT. This is the part of the CRT. So this having some vertical plates and horizontal plates and electron gun also. So here CRT, which is emits electrons that strikes the pass per screen internally to provide a visual display of signal. So actually this is the screen. So the screen coated with the help of fluoroscopic material according to our requirement. So here the electrons that strikes the pass per screen internally to provide so visual display of the signal. So this is the function of the CRT. So next one, vertical amplifier. This is the vertical amplifier. So actually here vertical amplifier is a wideband amplifier. So used to amplify signals in the vertical section. So that means actually here we have in CRT we have two plates, vertical plates and horizontal plates. Now you have to provide signals to vertical plates, vertical deflection plates and horizontal deflection plates. Now with the help of vertical amplifier, you have to provide um, amplified signals to vertical plates, vertical deflection plates. So next one, you can observe delay line. So it is used to delay the signal for some time in the vertical section. So actually now there is a gap between vertical amplifier and horizontal amplifier. So definitely you can observe some delay in the signals. Now you have to send at a time to vertical and horizontal deflection plates. That is the reason you have to cover time between the vertical amplifier and horizontal amplifier with the help of delay line. So next one, time based generator. So it is used to generate sawtooth voltage required to deflect the beam in the horizontal section. So actually with the help of horizontal amplifier, you can amplify output of the time based generator. The output of the time based generator you can observe in the form of sawtooth wave. This signal you have to provide to horizontal plates, horizontal deflection plates of the CRT. So next one, trigger circuit. So observe here, this is the trigger circuit. So this is used to convert the incoming signal into trigger pulses, so that the input signal and the sweep frequency combined synchronize. So actually here input signal we are providing to vertical amplifier, and we are taking sweep frequency from time based generator. So now here with the help of trigger circuit, so this will be synchronized. That means this is used to trigger circuit used to convert the incoming signal into trigger pulses, so that the signal, that the input signal and the sweep frequency can be synchronized. So this is the function of the trigger circuit pulse. So next one, power supply. So there are two power supplies. You can observe here, negative high voltage power supply and positive low voltage power supply. So two voltages are generated in the CRO. So the positive voltage supply from plus 300 volts to plus 400 volts. The negative high voltage supply is from minus 1000 to minus 1500 volts. So this voltage is passed through a bleeder resistor at a few milliamps. The intermediate voltages are obtained from the bleeder resistor for intensity, focus and positioning controls. So these are the parts of the CRT. So actually your CRT having some features. So features in the form of size, pass per, operating voltages, deflection voltages, viewing screen. So here size is also one of the important feature. So actually here size refers to the screen diameter. CRTs for oscilloscope are available in sizes of 1, 2, 3, 5 and 7 inches. So here 3 inches is most common for portable instruments. For example, a CRT having number 5GP. So actually here the first number 5 indicates that the size of the tube. So here 5 is the size of the tube. The horizontal and vertical viewing sizes of CRT is 10 centimeter and 8 centimeter respectively. So that means here 5GP1 will give idea about the size of the tube and horizontal and vertical viewing sizes also. So this is the one of the important feature. Next one, phosphor. So phosphor mainly using for the purpose of coated screen. So now the screen is coated with a fluorescent material called phosphor. This material determines the color and persistence of the trace. So both which are indicated by the phosphor and trace of colors in electrostatic CRTs for oscilloscope are blue, green, and but green, white is used in TVs. So generally maximum will try to use blue and green colors, but green and white is used for the TVs, and blue, white, orange and yellow are used for radar resistance. Is expressed as short, medium and long. So this refers to the length of the trace remains on the screen after the signal has the phosphor of the oscilloscope is designed as P1. First phosphor is a combination of the green medium. P2 is blue green medium and P5 blue very short and P11 um, blue short. So these are the combination of the phosphorus. So according to our requirement, you can use these arrangements. Is also changed based on the coloring system. And actually here, so we can observe screens are two types, black and white and color system. So to generate black and white screens, you have to take help of the only black white uh, phosphorus coating. To create color screens, you have to take help of the primary colors. So primary colors are blue, red, green. These are the primary colors. So now we have to arrange our required coating also according to our color requirements. So these are the arrangement of the phosphor. So actually here P1, P2, P5, P11 are the designators are combined in the tube type number. Suppose CRT number 5GP1 is a 5-inch cathode ray tube. So whose persistence is medium green trace. So one of the frequently used phosphor for photographing from the CRT is P11. So P11 is the blue short. So particularly this phosphorus combination using for the purpose of photographing. So these are the idea of the phosphoruses. So next operating voltages. So here operating voltages are also one of the important feature because of you have to provide sufficient power to CRT. So actually here CRT requires a heater voltage of 6.3 volts AC or DC at 600 milliamps. Several DC voltages are listed below. The voltage vary with the type of tube used. So first one, negative grid control voltage 14 volts to minus 200 volts. Positive anode number 1, focusing anode minus 100 volts to minus 1100 volts. Next one, positive anode number 2, accelerating anode 600 volts to 6000 volts. Positive anode 3, accelerating anode 200 volts to 20,000 volts in some cases. So actually these are the arrangements in internal of the CRT. So actually every CRT having some vertical deflection plates and horizontal deflection plates. So now here you have to provide to deflect deflection plates. So different voltages according to our requirement is also depending upon the internal parts of the horizontal deflection plates and vertical deflection plates. So next feature, deflecting voltages. So either AC or DC voltages will deflect the beam. The distance through which the spot moves on the screen is proportional to the DC or a peak AC amplitude. The deflection sensitivity of the tube is usually stated as the DC voltage or peak AC voltage required for each centimeter of deflection of the spot on the screen. So is also important. So now you have to provide sufficient voltage to deflection plates according to our capacity, according to CRT, deflection plates capacity. So next one, view screen. The viewing screen is the glass face plate, the inside wall of which is coated with phosphor. The viewing screen is rectangular screen having graticals marked on it. The standard size of used nowadays is 8 centimeters and 10 centimeters. Here 8 centimeter on the vertical and 10 centimeter on the horizontal. So each centimeter on the graticule corresponds to one division. The standard phosphor colors used nowadays is blue. This is the general. You can observe on TV screens also. So like this. So these are the features of the CRT. So now I will show some video on CRT. See this.
Cathode ray oscilloscope CRO.
So now
this device is
so
the
with the help
most
of
useful electronic instrument.
CRT, this is
Gives
the screen. You
visual
can see
representation
our
of electrical quantities
visible
such as
laser in the
voltage
form of
and
sine wave
frequency in
according to
any
our
electronic
providing
circuit.
signal input
It makes
signal.
use of the properties of cathode rays, which are deflected
This is
in
the tube.
electric and magnetic fields
So here
and produce
electric
scintillation
magnetic
on
fields,
fluorescent screen.
scintillation on fluorescent screen.
CRO consists of 3 sections: an electron gun,
Actually,
a
internally you can
deflection
observe one
system,
electron gun and
a
the deflection
fluorescent
system,
screen.
fluorescent
These
screen.
are enclosed in a glass tube which is completely evacuated. Electron gun.
So electron gun.
The electron gun consists
So
of
this
a
part
cathode K,
is the electron gun.
a control grid
This
G,
is cathode.
and along with them,
so you can observe some
two
center grid
anodes,
also like this.
A1 and A2.
This is the anode.
Electrons
Anode.
which are emitted from the indirectly heated
So it is
cathode
also
K
anode.
passes
These
through the
2
hole
points
in
are
the
the anode
cylindrical
points.
grid G
So this point is
towards the
cathode.
anode.
So middle you
Due
can
to the negative
observe
potential of
this
G
is
with
the
respect to
central
cathode,
grid. So
these
negative potential.
electrons bond together, forming a beam of electrons
This
coming
is
out
the
of
beam
G.
electronics. You
The
can observe
electron
here, this
beam
is
is
the beam
accelerated
electronics.
by the two cylindrical
You can
anodes
observe visual spot on CRT.
A1 and A2. Then the electron beam strikes the fluorescent screen.
So your screen is the coated of the
Deflection
fluorescent
system.
material.
With the help of two
Deflection
pairs
system,
of the
there
plates,
are two types of
X1,
deflection systems. One is
X2,
the horizontal and
Y1,
other one is the vertical.
Y2. The
So
electron
these are
beam traveling towards the
X
screen can be deflected.
plates and Y plates, so like this.
These plates are placed between the
So now you
path
can
of the
observe
beam
deflection
beyond the
movements
anode
are
A2.
like
Y1, Y2 plates are called Y plates,
Now we are providing
and
signals to
X1,
X
X2
plates and Y
plates are
plates.
called X plates.
That represents
The Y
horizontal and
plates are
vertical
kept
plates of the
horizontal
CRT.
and X plates kept vertical along the direction of the
This is the
beams.
vertical section.
The
These are the
electron beam will
horizontal
be
section.
deflected along the vertical
Here
direction.
X plates
If a
vertical,
DC
Y plates are the
potential is
horizontal
applied
section.
to Y plates,
So
and
you
the
can observe
electron beam will be deflected along the
vertical,
horizontal
right,
direction
like that.
with the potential on
So
X
next,
plates.
that passing through the horizontal sections, you can observe waveforms are like.
Fluorescent screen.
So fluorescent
The
screen
glass tube is coated with the
is this
fluorescent
one
material.
is coated with fluorescent
When the
material.
beam strikes the screen, a light spot is
You
visible.
can observe our visible
The electrons striking the screen
signals on the screen
are returned to
like
the power
this.
supply via the inner surfaces of the
So
glass
whatever
envelope,
display, that signal you can
usually coated with
focus on
graphite.
screen of the
This
CRT
coating is connected to anode
with the
A2
help of
by
electron
a
gun.
leaden wire. Uses.
So uses of cathode oscilloscope.
It is used to
It is
measure
used to measure
AC and
AC and
DC
DC
voltage.
voltages.
It is used to study the
So like
waveforms
this.
of AC voltages.
Actually, this is the sine wave.
It is
To
used to
represent
find the
AC.
frequency of
It is
AC
used to find
voltage.
the frequency of AC voltage.
It is
With
used
the
to
help of
study the
sine wave, you
beating
can
of
measure
heart in
amplitude,
cardiology.
frequency, time also like that. So this is the heart beating cardiology. So you can observe like this. So this is a small video on CRO. So next one,
Cathode ray
so I'm going
oscilloscope.
to explain parts of the CRT. So actually a CRT having combination of the vertical plates, horizontal amplifier, trigger circuit, time base, delay line, and voltage section. These are the parts of the CRO. Now I am going to explain one by one. Now our explanation is start from vertical amplifier. This is the first one. So actually here vertical amplifiers are the sensitivity gain and frequency bandwidth response. Characteristics of the oscilloscope are mainly determined by the vertical amplifier. Since the gain bandwidth product is constant, to obtain greater sensitivity, the black and white is narrow band or vice versa. Some oscilloscope give two alternative switching to a wide band position and switching to a high sensitivity position. So actually here this is the block diagram of the vertical amplifier. So this having parts as first one input attenuator. So with the help of input attenuator you can change input signal with according to our requirement. So next you can observe one amplifier and phase inverter here. So this part is called the input amplifier. So here with the help of phase inverter you can change the position of the signal, positive to negative and negative to positive like that. This is the phase inversion. So next part you can observe some driver amplifier and output amplifier. This part you can call as main amplifier. Finally you have to connect output of the output amplifier to CR. So this is the arrangement of the vertical amplifier. So now I will explain one by one. So here the vertical amplifier consists of several stages. Here first stage is attenuator. So with fixed overall sensitivity are expressed in volts per divisions. The advantage of fixed gain is that amplifier can be more easily designed to meet the requirement of stability and bandwidth. So the vertical amplifier is kept within its signal handling capability by proper selection of the input attenuator. Input attenuator switch. This is the input attenuator switch. The first element of the preamplifier is the input stage. So this part. So often consisting of a FET source follower. So this is the FET source follower whose high input impedance isolated the amplifier from the attenuator. So this FET input stage is followed by a BJT emitter follower. So to match the medium impedance FET output with low impedance input of the phase inverter. A phase inverter provides output with low impedance. So that means here with the help of phase inverter provides two anti-phase signals which are required to operate the push-pull amplifier. The push-pull output stage delivers equal signal voltages of opposite polarity to the vertical plates of the CRT. So actually in a CRT we can observe two vertical plates. For that plates you have to provide equal potential voltage, that may be either positive or negative. So whatever the polarity you should maintain equality. So this is the function of the first stage of the first part of the vertical amplifier. So here the advantage of push-pull operation in CRO are similar to those of from push-pull operation of the applications. Better hum voltage, cancellation from the source or power supply, that means DC, even harmonic operation. Essentially the large second harmonic is cancelled out and great power for tube as a result of even harmonic cancellation. In addition, a number of defocusing and non-linear effects are reduced because of neither plates is at ground potential. So this is the overall function of the vertical amplifier. Once again, I will give some idea about the blocks. First one is the input attenuator. With the help of this one, we can improve the signal strength. So next section PET input amplifier. So with the help of this section, we can change position of the signal, that may be either positive or negative. This is the complete inverse position. Next section, main amplifier. With the help of main amplifier, so you can call this as the push-pull amplifier. Finally, you have to provide equal strength of the signal to vertical plates of the CRT. So this is the function of the vertical amplifier. Next one, horizontal deflection system. So actually here horizontal deflection system having three blocks. One is the time based generator. So according to our block diagram, first one trigger circuit, second time based generator, horizontal amplifier. So here you have to provide input signal from vertical amplifier. So actually in block diagram of CRT, we have first stage as the vertical amplifier. After the delay, below you can observe trigger circuit. So here trigger circuit is the one part of the horizontal deflection system. So second one, time based generator. So actually here for trigger circuit you have to provide input signal from the vertical amplifier, and now you have to collect you have to provide signal to time based generator from through trigger circuit. So with the help of time based generator you can generate signal in the form of sawtooth. Now here trigger circuit maintains synchronization between the vertical amplifier and time-based generator. Last one, horizontal amplifier. Here we can observe two operations. According to that operations, we can control horizontal amplifier. So this is the overview of the horizontal depletion system. Now I will explain one by one. So first one, trigger circuit. So this is the block diagram of the trigger circuit. So actually this circuit having first one is the vertical amplifier. First block is the vertical amplifier, and this signal provide to comparator. So there is a one transformer. Here the output of the transformer 6.3 volts. Generally to operate any CRT, we need initially 6.3 volts. That's the reason you have to provide 6.3 volts to some trigger level. This is the trigger level, and you can observe on comparator also. Here comparator will compare output of the vertical amplifier and trigger and the transformer. Uh, so that means now you have to contact between the comparator and transformer with the help of switch. So switch modes you can observe external, internal, and the line. So other signal you have to provide to comparator from trigger level. So now this will compare signals of vertical amplifier. Comparator will compare signals of the vertical amplifier and transformer trigger level. So according to our operation is also depending upon the position of the switch. So finally here pulse generator will generate pulses. So this is the function of the trigger pulse circuit. So once again I will explain. The trigger pulse generator is activated by signals of a variety of shapes and amplitudes, which are converted to trigger pulses of uniform amplitude for the precision sweep operation. If the trigger level is set to low, the trigger generator will not operate. On the other hand, if the level is too high, the UJT may conduct for too long and part of the leading edge of the input signal may be lost. The trigger selection in a 3-position switch is internal here and external and line. So these are the our position of the switch. So actually that having modes as external, line, and external, internal, line. So like that. Here the trigger input signal is applied to a voltage comparator whose this one reference level is set by the trigger level control on the CRO front panel. The comparator circuit C produces a change in the output whenever the trigger input exceeds the present trigger level. The pulse generator that follows the comparator produces negative trigger pulses. Each time the comparator output crosses the quiescent level, so which in turn triggers the sweep generator to start the next sweep. The trigger sweep generator contains the stability or synchronous control, which prevents the display from the uttering the running on the screen. So this is the function of the trigger pulse circuit. So next one, time-based generator. So in the next class I will explain function of the time-based generator. Actually these are the parts of the horizontal deflection system. So actually horizontal deflection system having 3 parts. First one is the trigger pulse, second time base, and third one is the horizontal deflection system. So tomorrow I will explain. In the next video I will explain remaining functions of the time-based generator and horizontal amplifier. So these are the parts of the horizontal deflection system. So thank you.